Got a package in the mail. Looks like the date says September of 2014. And it is a Dorma ed400 controller. I never offered service for the ed400, but the 700 I have. Now this is very similar to the 700. Actually, it's probably very much the same and exact, except it uses a different processor that the 700 doesn't have. Now, to take this apart, you're going to have to do a couple things. And to remove the 4 screws on both sides. Let's get to that first. I'm going to continue moving around so I can get in here with my screwdriver. Typically what the problems are with these 99% of the time is the motor circuit has blown up. For whatever reason, Dorma really lacked in that engineering side of the motor circuit and its protection. They mass produced a lot of them, which is great for them. Good, glad they did that. But they also blew up in mass quantities as well. The uses of their MOSFET and a switching output for motor, a port with modulators, that sort of stuff, did not go well. I think they were probably ahead of themselves when they tried making this. This is a toothbrush, but it's from a previous video that I did for a thermometer. So I'll just ignore that. Company that sent this in did not state exactly what the problem was. They just said, "Did you work on blah blah blah?" And I said, "Yeah." And they never had any response to me, and they just sent it in, and that was the end of that. So I guess they accepted whatever I offered to them. Okay, so this is usually when they have a sticker up here, it's a rebuilt sticker, and it might have been rebuilt from some other company prior to the one that I used to work at. And yeah, it has to be, I'm guessing. And this is what the top board looks like. By the way, let's look and see how hot this thing runs. It's just amazing, isn't it? I can kind of smell the smell of something burnt and crispy. I'm going to show you how exactly I pulled this out. See how this capacitor is kind of leaning. Oh wow. I've actually never worked on this, apparently this style. I wonder if this is an older one or something they just redid. I'm not sure yet. So this is the top board. You can notice here the connection on this ribbon cable. If you had this locked and keyed or a clamp that goes around it, your wire connection probably wouldn't be like this. So, I mean, it can easily just, and that's, you know, vibration and this can disconnect. You can have all kinds of problems. So I think you should have fixed that issue. Look at this capacitor here. It's got a peak to it. So I know that capacitor is bad. That's interesting. Really, really interesting. Let's take off the top board, the digital board. as they call it. And the bottom board is the controller power. These are all the same threaded screws, so it doesn't matter when you take them apart. So ed400 is meant for low power for handicap doors. So I'm not going to have a lot of fast movements or anything like that. I would expect to see something blown up inside here, which I probably don't. So that's some soot from the transformer. I'm going to give the transformer a quick smell. It doesn't smell burnt, but it doesn't smell terribly good either. I'm going to look at the fuse here. See what the fuse looks like. Fuse apparently looks good. This is going to be a long video as I assess this controller. Because I want it to be a learning thing for you and me at the same time. And here is the motor output fuse. The other fuse was for the input, and it was fine. Here's the output. Visually looks good. It's great. Okay, so we have 1, 2, 3, 4, 5 more screws to take off. And these are loose. At least that one was. These have a star washer on the bottom in between them for whatever reason, so I'm going to keep those separate. I don't know why you would use a star washer, but whatever makes yourself happy. Different, a buffer board that they use to take and help with basically like a soft start from the motor. Originally they had one capacitor in there, and then they added a circuitry in there. But you have to take this circuit board off in order to get to the bottom part. I mean, I could take and get in between here and get at this standoff, but usually that's what the case is. I just need to find a pair of pliers or something that can get to the standoff. Or I can just like twist it with my little tweezers here. Isn't that loose? And some things that they should have been worried about using a star washer or a lock washer or even Loctite, they didn't. So that was kind of strange. Interesting. Okay, so we got the board out, and here's the rest of the case. I'm gonna set that off to the side. I'm gonna bring you down. Now, usually, what happens, you have a lot of these components just blow up. Now, on this one, I don't see any components that are blown up, which is great. I would look on the bottom of the board. Okay, that's gotten hot, which is typical for that one resistor. This transformer's gotten warm. For whatever reason, it's gotten so warm that it's baked off the manufacturer of this, the label for this transformer. It's a Triad. It's a good brand too. Triad's a real good brand. And I'm betting mostly it has to do with this capacitor here, with something overheating. I could be wrong, but fairly certain. Jamacon is probably not a capacitor I would use for door controls. Now the capacitor would be easy to replace. You see how this is kind of flat and it's not through hole. It kind of makes me wonder. See how this reads you up. That's just it's not all the way in, and it's solid. Got a connection, which is great. It's just not all the way in. Now we got to figure out the reason why this transformer gets hot. While I have this here, I want to take and get some photographs of the circuitry in this while it's not blown up and show you what they look like, or get some documentation of what they are before they are blown up. So this is I'm looking at this one here, so Q2, Q4, I believe, yep, they are different. So this is a F9640S, and this is a F644NS. And if I remember correctly, they are in pairs. And I would have to look underneath here. I don't know why this diode here is so goofy looking like that. I don't ever recall that being something. So on this side, Q2 and Q1 are the same. They are the F644NS. These are R100 resistors, which I think is just a 100 resistor, a 100 ohm resistor, or it's a 0.1 ohm resistor. These other guys here, R34 is a 100 ohm resistor. You see 100. So that R34, R37, R36, and one more over here with R35. They all usually will blow up when these MOSFETs do. U3 is a TC1428C. This diode's DN1, the marking on it is A7W. And DN3 is the same. You're going to be needing to know these parts in case you have something like this that's blown up. You can look and go back and go, okay, that's what that is. U5 is an HC132. U2 is an LM293. Actually, that was U1. U2 is, it says A00B, I believe. Could be an 8. D2 and Q5 are other culprits that blow up. I think one says it's a 1D, it's got a 2 on it, and the other one says KY2. And U6 is a, let's see here, I think it's a 236B15. So typically when stuff like this blows up, Q1 through Q4 is bad. Q5 is bad. D2 is bad. All the 100 ohm resistors are bad. The R12, R13 is blown up. DN1 and DN3 is blown up. Usually, this capacitor here is C19, C22, and the other capacitor underneath here, C23, is bad, typically. Sometimes I think R24 can go bad. You also want to check these diodes up here, these D11, D5, D7, and D9. I'm going to check that for shorts to see if that's what made this get warm. You can see how hot that got? That's really, it's kind of alarming. Something got that hot that it caused it not to work right. So that's usually what happens when something blows up. All these parts blow up, and you have to make sure that these resistors here are also not bad as well. Like R25, it's 3010 is the marking. R10 is 1001 marking. R11 is 1001 marking. I'm trying to get this for you guys so you can take in. When you see things blow up and you're looking at it, you can go, okay, that's what the part number is before yours catch on fire, because it's going to happen. So this crappy capacitor here, this 470 microfarad, 25 volt, it's definitely bad. I'm going to check these diodes here for shorts or low ohmage. This should not have any shorts at all. This board is not conformally coated whatsoever, and at this point it doesn't really matter. Some reason, there we go. Multimeter wants to work. Good. Alright, I'm going to go over here and measure D11. There's no short, that's great. D5 is good. Go to D7. He has nothing wrong with him. And then we're going to go to D9. And he also has nothing wrong with him. So, I'm not sure why that transformer got hot. Quite frankly, I don't know, what side caused what. If there's something else causing an issue. Do we have, look at the 24 volts output causing problems. Sometimes this board here, the digital board, will cause problems. I just want to zoom in and get into all this information. It's going to be valuable for you later on. I don't know why there's only 3 LED segments. Sometimes this switch will be bad. Got a lot of rust there. Out in the elements. Jumper. Okay. So, fuse is good. We got one bad capacitor. This is crispy. I don't know why. Who knows? Let me check these MOSFETs. Q4, Q3, 2, and 1 to make sure that they're still good. I don't see any shorts on them. It's probably the first one that I've ever looked at that didn't have any shorts, that didn't have anything blown up on it. This is really astounding. I guess I need to contact the guy that's in this in and ask him what's going on with it. That diode's fine. So the diode here, he's fine. Cool. Wow. And we show the arms across this diode, and there's a pad right here between the two, which makes sense. Okay, so I'm going to change this one capacitor here. I'll probably look at changing this one capacitor here. It's 47 microfarads, 16 volts, and that is C19. I think it was installed by the manufacturer. There's no flux on the bottom, so this is not a rework. This is actual, been done professionally. It's been cleaned up, which is good. It's also gotten warm. But I don't know if that means that it's bad. I'll get this part changed here, and then we'll power it up, see what happens. So I have not changed the capacitor yet, and we'll plug it into power now and see what it's doing. It's showing 888. Okay, so that's what it's doing. It's all the letters are on. All the numbers are on. You see that, 888. Okay, so let's get this removed. And now I'm going to change the capacitor out and see what happens. It's Panasonic ultra low ESR capacitors. May not be the same physical size, but it's going to fit in the same hole. You know, Panasonic is a good brand, and it's just better than whatever these people were called. Yageo. I don't know if that's how you pronounce it or not. I'm just throwing it out there. So, we got the capacitor. Got my crappy soldering iron heating up. Negative going this way, positive going this way. So we'll change the capacitor, then we'll plug it back in, see if it takes care of the problem. Alright, I got the cord plugged back in, and we'll plug it back in, see what happens. And there you go. No longer says 888. It says OPD. Now it's still on your screen because that's just a refresh rate on the LEDs itself. And that's what the problem was with this ed400. It's actually a pretty easy fix, and I'm really shocked. So, thanks for watching, guys. If you have any comments or questions, please let me know. Please consider subscribing. I'll see you next time.